Welcome to this online lesson on medicine through time. Is Jenner's vaccination the greatest invention ever? The aims of this lesson are to describe the work of Edward Jenner, to explain how Jenner used scientific methods in his work, and to evaluate the importance of Jenner's vaccination. You can pause the video here if you want to note down this as a heading. Okay, let's get cracking. The greatest invention ever. If you had to pick, what would be the greatest creation ever invented? Pause the video, give it some thought and note down an idea. Perhaps you put down the internet. Probably one of the greatest modern inventions, although it's approaching 40 years old now. Perhaps you chose the steam engine. Artificial power was the powerhouse of the Industrial Revolution, which revolutionised everything that we have in the modern world. Perhaps the printing press. This one's really important in the history of medicine. Of course, it allows the sharing of ideas accurately and reasonably cheaply and quickly. It was the internet of its day, you could say. Perhaps powered flight. Think about how different the world would be if we hadn't, in effect, shrunk the world with aircraft. Or perhaps the mobile phone, something that we use every day, and many of us couldn't really imagine living without now. So pick your invention. Give 3 areas it has impacted on. Maybe it's saved lives, maybe it's saved money, maybe it's increased knowledge. Then I'm going to ask you to sell it to me in 3 sentences. Of course, I won't be able to hear what you write down, but it'll give you a chance to really think about what the advantages of that invention are. Pause the video here while you complete this. So now we're going to have a look at what I think might be one of the greatest inventions ever. And this is on the basis that it's saved millions, that's right, millions of lives. 18th and 19th century breakthroughs. Write this down as a subheading. So far we've seen far more continuity than change in the history of medicine, but that stops here. Quick task, give 1 example of continuity and 1 example of change that we have studied so far. Pause the video while you do so. Okay, so an example of continuity would be the theory of the 4 humours, this being used as an explanation of disease from the Middle Ages right the way through to reasonably modern times, even though it's completely wrong. How about an example of change? Well, there's lots you could choose from, but how about we go with William Harvey and his circulation of the blood theory? Developments in the 18th and 19th centuries finally start to have the following effects. They actually help people live more healthily. This is something that hadn't really been possible with many medical breakthroughs earlier. They help people to live for longer. So here's another follow-up task. What aspects of medicine help people live more healthily and live longer? As an extension, we have chosen examples possible or likely to have existed in the 1700s and 1800s. Explain why. Pause the video here while you note down your answers. Well, in terms of having medical breakthroughs that help people live more healthily, actually knowing what the cause of disease was is a real breakthrough. So for example, if you understand that germs actually cause disease, you know that you're not just clearing up the streets for nothing, you're doing it with a specific purpose. But what about living longer? Think about treatments that may not have been possible before, the way that operations can now be done internally so that people can actually live longer and defeat diseases that otherwise might have killed them in the past. But were these examples possible or likely in the 1700s and 1800s? Well, as it turned out, germ theory is something that comes up in the 19th century with the work of Louis Pasteur. More on that in a future lesson. But living longer? Well, that's a more difficult one. If there's a way of wiping out a disease, or stopping someone getting the disease in the first place, then that would be a huge breakthrough. But without knowing what caused the disease, was this even possible? Well, in one case, as we'll see, yes it was. The positive effects of these developments is something that is still felt to this day. So we're going to create a significant breakthroughs timeline first of all. This will provide a bit of context and an introduction for this part of the topic. Breakthrough number 1, what we'll be focusing on in this lesson. 1798, Edward Jenner and vaccinations. This prevented smallpox, a very deadly and unpleasant disease, and it saved millions of lives. It has actually eradicated the disease. That means that the disease no longer exists in any practical sense. 1847, James Simpson. The chloroform anaesthetic. Therefore, surgeons could take longer to perform operations. Less pain, but people still died because of infection. 1861, Louis Pasteur and germ theory. This is a big one. Louis Pasteur suggested that bacteria and germs cause disease, but it took time to convince everybody. 1867, Joseph Lister. This one very much follows on from Louis Pasteur. Antiseptics. This greatly reduced the risk of patients dying of infection from operations. Germ theory was not accepted by everyone though, so again, Lister struggled to get his ideas adopted. And then lastly, 1882, Robert Koch. He identified diseases using germ theory and identified diseases such as typhoid. He could now develop new vaccines. This was building on the work of Jenner and Pasteur. So here's your tasks then. Firstly, list these developments in chronological order, then number them from 1 to 5 in order of importance based upon your opinion and your current understanding of them. This might change as you learn more. Secondly, identify which ideas are linked. I've given you a few hints about this already. And then thirdly, explain and evaluate at least 2 links between these medical breakthroughs. How did one lead to another? Pause the video here while you complete that task. Okay, in subsequent lessons we're going to look at some of these things in far more detail, but for today we're going to have a look at Edward Jenner. Smallpox, a defeated enemy? Smallpox is, well, was a very unpleasant and nasty disease. Yes, that poor man is suffering from smallpox there. If you were thinking it was going to be something like chickenpox, think again. This is far, far worse. It's entirely disfiguring and can often be fatal. Smallpox killed up to 60% of those who caught it, and those who survived are almost always left with permanently scarred and sometimes blind. Anybody, rich or poor, young or old, could catch smallpox, and people feared it as much as the plague. They feared it so much that some people had inoculations. They deliberately infected themselves with a weakened smallpox dose, but this could give them the actual disease if they were unlucky, so it was a really risky procedure. However, in 1979, the disease was declared extinct, eradicated, wiped out. So far, it is the only human disease to have been wiped out by medical action, and that's something that the world can be really proud of. However, that process began in 1796 when an English country doctor noticed something interesting about the local milkmaids. What on earth could I be going on about? Well, to begin with, you might want to pause this here and make some basic notes on smallpox, what it was, and its effects, so you can describe the symptoms or effects of smallpox. Then you can explain why people feared smallpox so much. Then explain why inoculation wasn't an effective defence against smallpox. And then explain why eradicating this disease would be so beneficial for humanity. Pause the video while you do those follow-up tasks. Done? Well, a quick recap. So smallpox causes those horrible boils over the face, can cause blindness, and anybody can catch it. People feared smallpox because there was no defence against it, and it was so deadly, 60% of people who caught it actually died from it. Some diseases more affected the poor, however this one could affect anybody. Inoculation wasn't effective because it didn't always work, and also you were risking catching the full disease, which would of course be devastating. So lots of people didn't want to risk inoculation, and those that did so terrified. In fact, as we'll see, Edward Jenner was one person who had an inoculation, and it had a big impact on the rest of his life. Why is eradicating this disease so beneficial to humanity? Well, it was such a common disease ever since antiquity that wiping it out has certainly saved millions of lives. Case study then, Jenner and vaccination. Edward Jenner was a rural doctor who was interested in science and nature. He noticed something curious. Local milkmaids had lovely skin and never seemed to get smallpox. He did notice, though, that they seemed to get the much milder disease cowpox. He wondered if there may be some connection. Perhaps the milkmaids who contracted cowpox were immune from smallpox once they had recovered. Some quick tasks then. Describe who Jenner was, describe what Jenner noticed about milkmaids, and explain how this led Jenner to investigate the link between smallpox and cowpox. Pause the video here while you complete that. Done? All right. Let's get some more info. Jenner decided to investigate his theory that cowpox infection prevented smallpox. Here's a source which is an extract from Jenner's notes. We're going to read it in a moment. In order to prove that this boy that he was experimenting on was immune to smallpox, he was inoculated or deliberately infected with smallpox pus, but no disease followed. Several months later, he was again inoculated with smallpox pus, but again, no disease followed. He was immune. Alright, this is pretty grim, but the source actually describes how Jenner achieved this feat of apparently inoculating or immunising this boy against smallpox. James Phipps. I selected a healthy boy about 8 years old. The matter, which is Jenner's word for pus, so it is pretty grim, was taken from the cowpox sore on Sarah Nelms, a milkmaid with cowpox's, hand, and inserted on May the 13th, 1796, into the boy by 2 cuts each half an inch long. On the 7th day, he complained of uneasiness. On the 9th, he became a little chilly, lost his appetite, and had a slight headache, and spent the night with some restlessness. But on the following day, he was perfectly well. So, read the source and describe Jenner's method. What's he actually done? Explain why Jenner's method was scientific. How did he prove his ideas? And lastly, explain why Jenner's experiment was unethical by modern standards. Pause the video here and complete those tasks. So, Jenner's method was to test to see whether someone infected by cowpox would later catch smallpox. So he took cowpox pus from a victim of that disease, which remember is quite a mild disease, and he deliberately infected a boy with it. After the boy had recovered from some mild cowpox symptoms, he deliberately infected him with smallpox and found that this boy was actually fine. He was immunised. But he did that twice. This is important for the next question. Jenner's method is scientific because he comes up with a hypothesis, that being that cowpox can immunise against smallpox. He experimented on somebody, and then he tested his idea twice by deliberately trying to infect them with smallpox twice. And on both occasions, this boy was immune. So he'd proved his idea. But quite clearly, this is hugely unethical. What if something had gone wrong? That boy would have caught smallpox and possibly been killed. It makes you wonder how much the boy and his mother was aware of what Jenner was trying to do. Perhaps he explained to them that he thought he had an idea for immunising the boy against smallpox, which of course would have been a very tempting thing to do. But it's not the sort of research that anybody could do now. So, in a nutshell, let's sum it up. Jenner noticed that milkmaids never contracted smallpox. That's probably not quite true, but they seldom did, especially if they'd had cowpox. He injected a young boy with cowpox, then infected him with a dose of smallpox to find he never contracted the disease. Vacca is the Latin word for cow, therefore the vaccination contained cowpox, meaning that the recipient would not then contract smallpox. And that's where we get the word vaccination from. Anything here missing from your notes so far? Well, check them over. If there is, add them now. Pause the video while you check. Alright, let's have a look at the impact of this. We're now going to use a graph to explain how successful Jenner's smallpox vaccination was. Okay, the graph isn't brilliantly clear, I've taken it from a very old resource, but it's fairly easy to understand. Along the x-axis we can see the year, from 1840 right the way through to the 1920s. Yes, this is a significant amount of time after Jenner's death, but it took a while for vaccination to really be ramped up. On the y-axis we can see the deaths per million from smallpox. The line therefore shows how many deaths per million there were in a given year, showing the rates of smallpox around the world. Crucially, vaccine laws are introduced, as we can see, in the late 1860s, but there appears to be a spike here. Remember that might not necessarily be caused by vaccination laws being enforced. It's more likely that the enforcement of vaccination laws was because someone noticed that there was an increase in smallpox. And in fact, the vaccine was only strictly enforced at the peak of the epidemic there, and afterwards it plummets. So, you can use these sentence starters to help you explain and describe the graph. Pause the video here while you sum up what the graph shows you. Okay, So the graph shows the changing rate in smallpox vaccinations, but also the deaths per million. It starts fairly high. There is a spike in the late 1860s and into the 1870s, and then by the 1920s it's virtually died out. Jenner's smallpox vaccination was successful to a degree, especially during the 1880s to 1900s, because of the dramatic decrease in deaths per million from smallpox. However, only when vaccination was strictly enforced do we see this reduction. This meant that the vaccine was effective in stopping smallpox, because by 1920s there's hardly any left. Have a look at this rather strange cartoon. It was produced by a famous cartoonist of the day called James Gilray, who was famous for his quite grotesque depictions and humorous and often exaggerated depictions of current events. At the bottom it says the cowpox, or the wondrous effects of the new inoculation. It says that this was produced for the publications of the Anti-Vaccination Society. So it is likely that this is not positive towards Jenner. Remember, new ideas are often not accepted right away, and it takes time for them to be proved for the satisfaction of all. We're going to study this source in some detail now. 18th century anti-vaxxers. Here's the source again. Source A. 1802 cartoon of Jenner giving people his vaccine, drawn by James Gilray, a famous cartoonist. The caption reads, "The cowpox, or pox, or wonderful effects of the new inoculation," published by the Anti-Vaccine Society. We're going to do an exam style question to analyse this source. Here it goes. Study source A. What can you infer from source A about people's reactions to Jenner's smallpox vaccination? Now, to do this, you need to infer by reading between the lines. And what I mean by that is you've got to go beyond the obvious. For example, if you said, cowpox vaccinations made cows jump out of your nose, that would clearly be nonsense. You've got to go beyond the obvious and say, what does this actually mean? And then you can identify the bit in the source that gives you that clue. Do that twice and you've got yourself 4 marks. You should spend a maximum of around 6 minutes on this. If you're able to, get your own copy of this picture, and it just makes it easier to circle or highlight various parts of the picture. Pause the video now while you do this. How did you get on? Well, let's have a look at an example answer, and perhaps you can improve it if you need to. Here's the source again, and here's an example answer. I can infer that people feared the new vaccination. The detail in the source that tells me this, the artist has shown people panicking with cows leaping out of their sores. Not that that should be taken literally, of course. I can also infer. I can infer that many people took Jenner's vaccination. Detail on the source that tells me this, even though this image is against vaccination, it shows crowds of people queuing to have it. There are so many other inferences that you could have about this, but just to make sure it's got to be about reactions to Jenner's smallpox vaccination, not the process or the science behind it, for example. So that's why you need to read the question particularly carefully. The significance of vaccination. Explain the significance of Jenner's smallpox vaccination in the fight of infectious disease. This is a 12-mark exam style question. However, the Edexcel paper allows you to get some stimulus material to go with these. You may use the following in your answer: inoculation and the eradication of smallpox. You must also use information of your own. Remember, it's always a good idea to use the stimulus points because you know that they're going to be relevant. However, you don't have to. But if you only include information from the question and none of your own, then you are limited in the marks that you can get. So let's consider ways that Jenner's vaccination was significant and the way that Jenner's smallpox vaccination was of limited significance. Create a table like this one here. In a moment, I'm going to show you a group of cards, if you like, which you're very welcome to screenshot and print for yourself. Cut out the cards and place either of them in the relevant columns. Alternatively, you can just copy them out. Then choose 3 to 4 examples that you think shows vaccination was of significance. Then as an extension, how important was Jenner's vaccination in the fight against the wider infectious disease, not just smallpox? After that, we'll have a go at answering the exam style question. So this is very much preparation. So when you're ready, I'm going to show you the cards. Let's have a look at these cards then. When I've displayed them all, you can screenshot them and maybe print them for yourself. Alternatively, you could just write them down. Stopping smallpox was not new. Opposition to the vaccine. Jenner showed the value of scientific method. Inoculation, and that's not the same thing as vaccination, remember, had limited impact on smallpox. Vaccination saved many lives. Vaccination was not enforced for many years. Vaccination did not lead to other breakthroughs. And Jenner didn't understand how vaccines worked, but others later found out. Okay, if you pause this here, you can take a screenshot of this information, you can sort them for yourself, or if you prefer, you can copy them into the different tables, showing which ones show that vaccination was significant, and which ones show that it was of limited significance. There is more detail on here. If you're struggling to read it, I recommend playing this video full screen and in HD quality. So, once you've got that sorted, pause the video and have a go at the task. Sort them between significant and limited significance. Well, let's carry on by having a look at what I think. You might disagree, but I think I can support my answers. Stopping smallpox was actually not new because of inoculation. This arguably shows that vaccination was of limited significance as there was an existing treatment. Opposition to the vaccine also shows that it's of limited significance because fewer people took it up, although later rates improved. Jenner showed the value of scientific method. That shows it was significant. If it worked for Jenner, it could work for other people. Inoculation had limited impact on smallpox, but as it says in the extra information, most people could not afford inoculation, but Jenner gave his vaccination for free with government help. That means that more people could take it up, so it was significant. Vaccination saved many lives. That's very clearly significant. Vaccination was not enforced for many years. That shows it's got limited significance in early years, but you might have put it as significant later on. Vaccination did not lead to other breakthroughs. That shows it's of limited significance. Actually, vaccinations did increase later on, but that was once it had been identified how they actually worked, which Jenner never did, which shows that Jenner didn't understand how vaccines worked, is actually quite significant, because later scientists like Louis Pasteur and Robert Koch built on Jenner's ideas to work out how vaccines worked and to develop vaccines that prevented other diseases such as rabies. If Jenner hadn't done his work first, even without knowing how it had worked, then Pasteur and Koch would not have known where to start. Okay, make any corrections and additions that you need to, and you can pause the video while you do so. Finally, you could go back a few moments in this video and have a go at that exam answer question, although I'm not going to demonstrate it this time. Remember though, you'd need to explain 3 specific examples that made Jenner's vaccination significant, and you should have got the information for that now. However, to conclude this lesson, let's have a look at this. Firstly, describe Jenner's smallpox vaccine. Then explain why this was an important breakthrough. Explain how far you agree that Jenner's vaccine is the most important invention ever. Pause the video while you do those things, and then press play when you're ready to conclude the lesson. Well, arguably, Jenner's vaccine is the most important invention ever because it's an invention that has wiped out a very deadly disease that has blighted humanity pretty much forever. So, it's good that we no longer have smallpox. It's even better that we now have new vaccines. And Jenner might be the one that we can thank for this. Is it the most important invention ever? Well, that'll have to be up to you. But I think it's right up there. That concludes this lesson. Thanks for watching. I hope it's been useful. And if it has, subscribe to the channel, like this video, and there'll be more content like this soon. Goodbye.